It has been unusually cold across the eastern third of the United States and much of Canada, with temperatures 20 to 30 degrees Fahrenheit below average for this time of the year, and many daily cold temperature records have been broken. It has been so cold, in fact, that people are ice skating on the ocean off the coast of Maine. On the flip side, many places in the western United States and elsewhere in the northern hemisphere are warmer than average for this time of year. What is particularly striking is that record lows and high temperatures are being broken across the United States at the same time. What is also striking is that despite the cold end to 2017, it was the third warmest year on record in the United States. The extreme cold weather in the eastern United States has been caused by a prolonged outbreak of cold air from the Arctic. Most of the time, cold polar air is trapped in the Arctic by the jet stream. That's a fast-moving ribbon of air that flows from west to east high above us in the atmosphere. You see, it acts like a fence or wall, keeping all of the cold air penned in to our north. Occasionally, cold polar air breaks out of the Arctic as part of what's called a trough or dip in the atmosphere, where cold air flows abnormally far southward. This happens when the jet stream becomes weaker, slows down, and begins to meander further south. So instead of trapping the cold air in the Arctic, it is allowed to escape southward. These outbreaks can happen every winter, but the current outbreak is particularly unusual as it has lasted for an extended length of time. Let's look at the progression of this winter's outbreak, from December 27th, 2017 through January the 3rd, 2018. You're looking at lines called isobars that connect equal atmospheric pressure readings. And what we begin to see is a dipping down of these lines over the eastern United States. This is called a trough. It is this trough that allows polar air to flow southward and bring extremely cold temperatures with it. The opposite is going on over the western US, as what's called a ridge allows warm air to move northward. So in these maps we can see the very cold temperatures in the east and much warmer temperatures in the west. Along with the cold temperatures, those in the northeast have experienced an intense winter storm called a bomb cyclone. The bomb refers to rapid intensification that can be caused when relatively warm air off the Atlantic Ocean collides with the cold polar air, creating a lot of uplift and a strong storm. This is also often referred to as a nor'easter. This one was particularly bad because of the huge temperature gradient between the relatively warm ocean air and the frigid air moving southward from the Arctic. These storms get their energy from such temperature gradients and they can produce a lot of heavy snowfall. Following this outbreak, we can see the trough retreating back northward and the lines flattening out and once again retaining cold air in the north. But over the last few days, a trough has returned, leading to more extreme cold temperatures and snowfall over the eastern US. So what about climate change? Are the recent extreme cold air outbreaks caused by climate change? Well, I think it is important to realise that weather is chaotic in nature, and that while the world is certainly getting warmer under climate change, it will still always be colder in the wintertime. To explore the link with climate change, let's look at this figure again. Remember that what keeps cold air trapped in the Arctic is the fast-flowing jet stream. The jet stream is driven by temperature gradients, just like the bomb cyclone is. The big north-south temperature difference is what keeps the jet stream flowing. Under climate change, the wintertime temperature gradient across the northern hemisphere will likely decrease as the Arctic continues to warm at a faster pace than the rest of the globe. So what's happening is the Arctic is getting warmer at a faster rate than everywhere else. So if it's warming more and everywhere else is warming a little bit, we will see them equaling out in terms of temperature. There will not be as steep a temperature gradient between the cold Arctic and the rest of the globe. And if there is less of a temperature gradient across the northern hemisphere, the jet stream will weaken and meander more, leading to more of these kinds of conditions where cold Arctic air escapes southward. So we will always have cold winters and cold air outbreaks just like this past winter, but climate change may make these extreme cold events more likely.